Welcome once again to this introduction to Microsoft Office applications. And in this session, we're going to have a brief introduction to Excel 2013. And as we said from the past, that whether using Office 2007 or Office 2010, the features and the user interface are pretty much the same. So in this session, to launch the Excel application, we'll have to either click on the Excel icon on the desktop or click on the Start button, which is in the bottom left corner of your computer, and you search for Excel. And again, we're using Windows 10 operating system, but you could as well be using Windows XP or Windows 7 or Windows Vista. It's the same thing. Launch the application and shall start up. Once it launches, it's supposed to look like this. Once it launches, you will be presented with a user interface of Excel, and as you can see that there is not much difference compared to the interface of Word. Only a few changes happen, but the layout remains the same. And you can see the tabs in the ribbon. Still have the home, insert, page layout, formulas, with just a slight difference with formulas, data, review. Otherwise, most of the other functionalities are the same as the word processing application of Office. And down here, you can still see there are still the same view items, and the quick launch is still there, and the file button is still there as well. So with a new addition of content in here, what do we use Excel for? We use Excel to store and organize data, 2, to analyze data, and 3, represent data graphically, as for example in bar graphs, histograms, and scatter plots. And during this session, we will be discovering each of those. Excel spreadsheets organize information, that's text and numbers, by rows and columns. This right here is row number 1 that I've selected. And this is row 3, row 6. And this is a column right here. It's column A, column B, column C, column D. And this is a cell, and a cell is referred to by its reference, which is the column and the row number. So this cell right here is referred to as C5. That's column C and row 5. This right here is column D and row 7. Data in Excel is entered into cells by simply typing on a keyboard. For example, I can say data 1, and by pressing the arrow key, the right arrow key on my keyboard will take me to the other cell, data 2. By pressing the enter key will take me to the bottom cell. By pressing the left key will take me to the adjacent cell. That's how you enter data within Excel. Insert this data into your Excel workbook as follows. And most times when you're working in Excel, you will be dealing with some computations on figures within your cells. So I would draw you to 2 important features of Excel: formulas and functions. Formulas are equations that perform calculations in your spreadsheet. Formulas always begin with an equal sign. When you enter an equal sign into a cell, you are basically telling Excel to calculate this. And functions are Excel defined formulas. They take data you select and enter, perform calculations on them, and return values. As an example on formulas, you can calculate either an addition, subtraction, division, or multiplication by simply entering the equal sign in your keyboard and typing a number and using any of the either multiplication and pressing enter. It will give you the answer. And when you click on the cell up here, it shows you in the formula bar what formula was used to calculate the value in the cell. But you can also, however, use cell references in your formulas. For example, I want to multiply the value in B5, this one here, by the value in C4. So what I simply do is this equal sign again to tell Excel that this is a formula. B5 multiplied by C4. And as you can see that Excel identifies for you what cells that you're selecting. With a simple enter key, I will get the resultant value, which is 11.6. And clicking on that cell, I will have the formula within the formula bar up here. Okay, now that we have seen a basic example on how to use formulas, we're going to couple a formula and the functions. All functions have a common format: the equal sign followed by the function name followed by the input in parentheses. The input for a function can be either a set of numbers. For example, if I want to find an average of a given set of values, I'll start with equals and type average. And as you type the name of the function, you will see that Excel gives you a help recommendation of the available functions as you type. So by completing this, you have to enter the parentheses. You have to open the parentheses and then enter the numbers. I want to find the average of 3, 5, 7, 4, 3, 7. After inputting the set of numbers, then you close the parentheses and hit enter for Excel to return for you the average value for those numbers. And here is our average number value as computed from this set of numbers as seen in the formula bar. So in Excel, most functions will take on that format, but also you can be able to apply the same function on a range of values within a column or within a row. For example, if I want to find the average value on a range of values in the column B from B2 to B11, and that's to say the mean. I want to find the mean of values between B2 and B11. What we do, equals, again, we want to find the average, open the parenthesis. To specify ranges, you specify the first cell reference and the last cell reference of your data, and you split the two using a full colon. B2 full colon to B11. And as you can see, Excel has selected the range of values as specified by your input, and by hitting enter it will give me the average value between B2 and B11. The same thing applies for data 2 values. You can put in the formula for yourself right now. If you didn't put in the formula for yourself, it was equals average C2 full colon C11, close the parenthesis, enter. To find the median of values in data 1 column from B2 to B11 equals median B2 to B11. Another interesting feature in Excel is that you can be able to duplicate formulas across rows and columns without you having to retype the formula again and again. For example, I want to duplicate this same median formula to data 2 in this cell. What I do is I hold down on my mouse, my left click button, I hold down and I drag to the right and release. When I release, it has applied the same formula on data in column data 2 from C2 to C11. And as you can see, when I click on that value in this cell C13, I can see in the formula bar that the formula is median C2 C11. Mode. And as you can see, I will again drag. To get the variance as well, I'll also have to use a formula. For the variance, I'll use the formula var p, and this formula is compatible with your earlier versions of Excel, that is Excel 2007. So I'll use var p to calculate the variance. Open parenthesis B2 to B11. Enter. So that's the variance. And I'll drag to give me the variance of the data 2. Standard deviation, again we'll use the formula that is compatible with earlier versions of Excel. Open parenthesis, specify the data range, press enter. And if I drag this to give me the value of the standard deviation in data 2. So in this section we have shown a brief of functions for descriptive statistics. In this section we are going to look at some extra functions in Excel and some plotting features, and we will look at some correlations. Correlations can either be in a positive sense or negative sense. Positive correlation depicts that high scores on one variable are associated with high scores on another variable, whereas negative correlations are associated with high scores on one variable being associated with low scores on the other variable. Every correlation has a magnitude or strength. The closer the correlation coefficient is to +1 or -1, the stronger it is. The closer the correlation coefficient is to 0, the weaker it is. Correlations are described using the Pearson product moment correlation statistic, or the R value. In Excel, there are many functions that can calculate a correlation statistic. However, we will only use equals Pearson, which is written in this manner. Equals tab Pearson. Let's say we want to determine if there is a relationship between number of hours spent per week studying for this course and the GPA earned in the class at the end of the period. To do so, we can calculate Pearson's R for two variables, that is the study hours and the GPA, which is the grade point average. So what we need to do, let's get rid of this first. What we need to do is to select the cell where you want your R value to appear, and we may have to label it. So probably want our R value to appear here. One can give it a title here, study hours versus, and we now click on the function wizard. The function wizard is this symbol here, fx, that is just right next to the formula bar. It will bring up for you a list of all functions that are available for us to use in Excel. So by clicking on it, to bring me up this dialog box here, and I can be able to search for the formulas that I want. So by just typing in this space here, Pearson, and hitting go, it will search for all related formulas with that word Pearson. So I will select Pearson and click OK to bring up the contents for the Pearson formula. For array 1, we will input our first variable, and which are all the values under the study hours column, and that is in the B column, and all the values under study hours, which is B2 to B11. So what I do, you select this button right here, and which you basically drag down to highlight all the values in B2 and in column B under study hours, which is from B2 to B11, and release. When you're done, you can click on this button here again to bring back the full dialog box. For array 2, selecting array 2 and click on this button and click drag down by holding down your left key on the mouse up to from C2 to C11, and when you're done, release the mouse button and click back to bring back. So you can see that already it has calculated the R coefficient. Okay, and array 1 was the independent value, and array2 was the dependent value. So when I say OK, I will get my answer here for the Pearson correlation. Scatter plots. A scatter plot is an excellent way to visually display the relationship or correlation between two variables. Each point on the scatter plot represents an individual's data on the two variables. We will now create a scatter plot for study hours and GPA. The first step is to select both columns of the variables that you wish to plot, that is study hours and GPA, by holding down the mouse button, the left mouse button, and dragging to select all the data. And when you're done with this, you go to Insert tab on the ribbon, and you head over to Charts, to the Charts sub tab, Charts, select the arrow, and choose the type of scatter plot that you want to use. And as you move through the different scatter plots you will be seeing on your screen, we select the first one, and this is our scatter plot. We, however, can go ahead to add content to our scatter plot. Either add a note on the X and Y axis by changing the title and all those things. You need to make sure you label your axis with the proper variable name. In this example, GPA is the title, but this is not true because the scatter plot is both study hours and the GPA. So you can change the title for the scatter plot by selecting the title and double clicking on it. Double clicking, you left click twice on your mouse. Study hour. You can also add chart elements by clicking on this plus sign next to the chart and selecting which elements you want to add. You may want to add axis titles, and in this case we've added both X and Y axis titles. And on X we have added study hours, and on the Y we have the GPA. With that done, you'll have your nice scatter plot showing your two variables, and it's now finished. Thank you for listening in this Excel tutorial.